Okay, so in this session we will discuss about how to solve assignment problem. Assignment problem means we need to assign one job to one machine, or you can say one person, and their associated cost or associated time. So sometime in assignment problem the objective will be minimize the cost, or also you can say the minimize time, and there is the constraint one job you can assign to the one person. Okay, so now here you can see in this particular problem there is the three job 1, 2, 3, and one job I need to assign to the one typesetter. Like that the total cost will be the minimum. How to solve this problem? We can also solve this problem with the linear programming, but linear programming easily can solve this kind of a problem. But if the number of job is more than 20, 30, number of machine are 20, 30, in that case that much permutation combination require lot of computing power, and that we can't solve with the simple Excel solver or the LP. Okay, so there is the one method that is in the assignment known as the Hungarian method, right? And how to solve this particular problem with the Hungarian method, that we try to see here. So what we need to do, okay, this is the table. I quickly make this table, just give me 1 minute. Okay, there is the first, you can say the A, B and C typesetter, and with respect to the cost for job 1, that is the R34, is 11, 14 and 6. For job 2, that is the S66, 8, 10, 11, and for job 3, that is the T50, 9, 12 and 7. Okay, how to solve this problem with Hungarian method, that we try to discuss here. First, what you need to do here, you need to apply the row operation. Okay. In row operation, what I will do, I will select the minimum number in this row. Which one is the minimum? 6. Here the minimum number 8. Here the minimum number 7. So that number I subtract with each element of that row. So I try to do that. Okay, so 11 minus 6 is 5, right? 14 minus 6 is 8. 6 minus 6 is 0. Okay, 8 minus 8 is 0. 10 minus 8, 2. 11 minus 8 is 3, right? 7, so 9 minus 7 is 2. 12 minus 7 is 5. 7 minus 7, 0. So row operation is done. Now what you need to do next is the, you can say the column operation. In column operation, okay, this is the operation management scheduling problem. What I need to do, okay, in column also I will see the minimum number. Here, what is the minimum number in the column 1? 0. In column 2, 2. In column 3, 0. Okay, so only column 2 will change, right? Okay, after column operation, I will see in this first column what is the minimum number 0, that I will subtract with the each element of the column 1. So 5, 0, 2. Okay, then 2 I will subtract with the each element of column 2. So here 6, 0, 3. Here 0 is the minimum number, so 0 subtract to the each element, you will get as it is, right? So this is the column operation. So once row and column operation done, then what you need to do, you need to draw okay, you can say the horizontal and vertical lines, okay, and that should be the minimum. Draw minimum horizontal and vertical line that cover all 0, that covers all zeros, right? So I need to draw the line. So I will try to draw. Okay, if I draw this line and if I draw this line, by one vertical and one, you can say, the horizontal line, I am able to cover all the zero. Now what Hungarians say, okay, if no line, in that case what we need to do in this table, no line. Okay, if double line, then what we need to do, here double line also present, right, on 3. And if single line, then what we need to do, first after drawing this particular lines, okay, we need to see the minimum number. Okay, in the remaining, okay, we already draw the two line and then cover the some number. Now some number are not covered number, then we need to identify the minimum number, and the minimum number here is 2. So if no line, in that case what I need to do, subtract that number. Okay, if there is the double line, then addition we need to do with this, you can say, minimum number, uncovered minimum number. And if single line, then no change. Okay, so now if I apply all these steps, and let's see what will be the result. Okay, the first, there you can say no line, I need to do the subtraction. Okay, with 2, because 2 is the uncovered minimum number, right? So I will subtract. 5 minus 2 is 3, 6 minus 2 is how much, 4. And if single line, no change, as it is I will put. This is single line as it is, 3 double line, we need to do the addition. So 3 plus 2, 5. Okay, then you can see 2 minus 2 is 0, because no line will subtract. 3 minus 2 is 1, and 0, single line, no change. This will be the new table after applying the Hungarian, you can say, the method. Now I will do the assignment. Okay, so I will check the single 0 present in row 1. Yes, single 0 present, so I will do my one assignment here. In second row, single 0 present, no. Okay, so once I will do, okay, in the row 1 the single 0 present, I will do the assignment, and in that corresponding column, if any 0 present, that we need to cross. Second, there are how many 0 present, 2, so I will leave. Okay, in third, how many 0 present, 1. Okay, assign corresponding column, if any 0 present, that you need to cross. Okay, now I will go column wise. Already assignment done. In second column, yes, single 0 present, I will do the assignment, corresponding column 0 present, no present. Okay, so this will be the assignment. Now I will see, okay, I will put all this here. Okay, you can see 6 plus 10 plus 9. So what I will do, okay, here you can see I will assign job 1 to the C, okay, typesetter. Job 2 I will assign to the B typesetter, and job 3, or you can say the T50, I will assign to the A typesetter. In that case, the cost will be the 6 plus 10 plus 9, and that is, you can say, 25. So this particular task you can complete in minimum cost 25. You can't reduce. This is the optimal solution. Okay, and this we are solving with the help of Hungarian method. So thank you very much. This is all about the Hungarian method. Thanks a lot.